In this video, we're going to explain to you the bracing procedure. We're going to talk about the types of bracing, its variables, and its advantages compared to other welding or melting procedures.
General description. It involves a plastic deformation of the base metal. Coalescence is produced by heating a suitable temperature about 450 Celsius and by using a ferrous or non-ferrous filler metal that must have a liquidus temperature about 450 degrees Celsius and below solidus temperature of the base metal. The basic steps for doing bracing is, first of all, the region of the parts to be joined is heated to a temperature of at least 450 degrees Celsius. Second, the parts and bracing filler metal reach a temperature high enough to melt the filler metal, but not the parts. Third, the molten filler metal held in the joint by the surface tension spreads into the joint and wets the base metal surfaces. And fourth, the parts are cooled to solidity. The filler metal, which is held in the joint by capillary attraction and anchors the parts together by metallurgical reaction and atomic. On this table, we can see different types of filler metals used for bracing applications. We could see the composition of each filler metal and also the liquidus and solidus temperatures in degrees Celsius and Fahrenheit. The most important variables involved are filler metal flow, base metal characteristics, filler metal characteristics, surface preparation, joint design clearance, temperature and time, rate and source of heating, and finally protection by an atmosphere or flux.
A braced joint is not a homogeneous body, but rather it is heterogeneous, composed of different phases with different physical and chemical properties. In the simple case, it consists of the base metal parts to be joined to the other filler metal. However, partial dissolution of base metal combined with diffusion processes can change the composition. Advantage: economical fabrication of complex and multi-component assemblies, simple method to extensive joint area or length, joint temperature capability approaching that of base metal, excellent stress distribution and heat transfer properties, ability to join non-metals to metals, ability to join metal things that vary widely in size, ability to join dissimilar metals, ability to fabricate larger assemblies in a stress-free condition, ability to preserve special metallurgical characteristics of metals, ability to join fiber and dispersion strengthened composites, capability for precision production tolerance, reproducible and reliable quality control techniques. Family process of bracing. We have many types of bracing. First, block bracing, carbon arc bracing, twin carbon arc bracing, diffusion bracing, deep bracing, electron beam bracing, exothermic bracing, flow bracing, furnace bracing, induction bracing, infrared bracing, laser beam bracing.
This is a process where the heat is obtained from fixed blocks. Block bracing consists of configuring the desired materials in splicing at least one flat face between both materials. The filler material, for example a silver alloy, is to be positioned between the desired brace materials. When heating on a furnace, the system is to hold together with nichrome wires, and when using a torch, a holding rod would do the job. In carbon arc bracing, an arc is generated by a set of carbon electrodes. When the arc is generated and the workpiece is heated up, The operator puts a filler material rod in the desired area.
There's been a huge resurgence of interest in diffusion bonding at TWI. Indeed, it's invested in a rather unusual machine to do just that, on longitudinal section, as Alec Gunner explains.
We've been diffusion bonding here at TWI for the last 41 years now. In the early days, there was obviously a lot of interest about what this technique might be able to deliver.
Electron beam brazing provides a vacuum atmosphere in which the workpiece receives a high concentrated photon laser beam. This brazing is really thin, located, and can go very deep. The heat affected zone in this process is minimum as well.
Exothermic brazing. This kind of brazing, as its name says, is carried by an exothermic reaction, where the metal is combined with a mixture that ignites and heats the metal above its fusion point. As it melts, the metal fills the space between the materials desired to braze, usually inside a proper mold. Using a wire brush, clean our surfaces. Remember to keep everything clean without moisture or any residue. After this, prepare the mold by heating its interior with a propane torch, which is only necessary for the first weld of the day. Then, you need to make sure the materials are touching at the desired joint. Fill the mold's interior with the steel disc and weld metal. Using the proper tool, ignite the weld metal and wait until the mold is cooler. Then, clean the mold and visually inspect the resulting braze. Infrared brazing. Infrared brazing uses focused light energy, typically from high-intensity quartz bulbs, to heat components to braze temperature. Infrared brazing's fast thermal cycle achieves an optimized microstructure. Remember to be careful with the non-metallic components, because they may also be heated. In infrared brazing, you must have a transparent quartz chamber that surrounds the assemblies. In some instances, a thin-walled refractory tube may also be used for atmosphere containment. But using a refractory tube, the heating rates are generally slower. The fast thermal cycle achieved in infrared brazing achieves an optimized microstructure, and rapid heating and cooling rates are also possible, which can make infrared brazing suitable for meeting high production requirements. Laser beam brazing. Its three main advantages are high mechanical stability, minimal heat affected zones, and smooth surfaces. It works by a filler metal or alloy that needs to be heated to temperatures above 450 degrees Celsius and distributed between two or more close-fitting parts, without actually melting the base metal. The laser is used to heat up the wire material, which will then flow in between the two closely fitted joint materials. Let's keep in mind that we are not welding. The joint materials are held together due to wetting by the filler material. Therefore, the joint materials do not necessarily need to be of the same material, as it allows to leave very smooth surfaces, and therefore is often used in the outer car skin areas, where the joints have to be visible to the eye. Resistance brazing. As a resistant brazing joint process, the workpieces are heated locally, and the filler material that is replaced between the workpieces is melted by the heat generated from resistance to the flow of electric current through the electrodes and the work. In the usual application of RV,
the heating current is passed through the joint itself. Equipment is the same as the used for resistance welding, and the pressure needed to establish electrical contact across the joint is ordinarily applied through the electrodes. Resistance bracing is used for many applications involving small workpieces, for small joints that are part of very large equipment, or for low volume production runs because it provides very rapid and highly located heating, flameless, clean operation, precise bracing that is easy to control, high quality joints without extensive operation training equipment. The equipment is low cost, so there is some cost savings. It is also have easy portability in some of the equipment. Torch bracing. There are three main categories of torch bracing in use: manual, machine, and automatic torch bracing. Manual torch bracing is a procedure where the heat is applied using a gas flame placed on or near the joint being braced. The torch can either be handheld or held in a fixed position depending on whether the operation is manual or has some level of automation. Manual bracing is most commonly used on small production volumes or in application where the part's size or configuration makes other bracing methods impossible. Machine torch bracing is commonly used where the repetitive brace operation is being carried out. Automatic torch bracing
Blow it around.
bracing operation,
We
except
didn't need to
for
grind
loading
it, do any type of
and
machine
unloading
work. This is the way the
of the machine.
SSF6 finishes.
machine.